Good day. Today we're going to continue our discussion about the probability of an event. We're going to have more examples about counting techniques. Let's have this first example. A witness to a hit and run accident told the police that the license number contained the letters RLH. So it would be RLH, followed by three digits, which was the first of which was a 5. And then after that, we have additional two digits. But it is certain that all three digits are different. So that means we can't use 5 anymore. Find the maximum number of automobile registrations that the police may have to check. So where are we going to take this last two digits? That would be taken from 9 other digits, and we're going to take two more digits, so 9 permutation 2. So we are going to select two digits from the 9 possible digits, and then um, we're going to arrange that to the last two digits of the license plate. So this is equivalent to 9 times 8 equal to 72. In how many ways can 6 people be lined up in a bus? So for lining up, it would be 6 factorial. So this would be equal to 6 times 5 times 4 times 3 times 2 times 1. So that would be equal to, yes, that is 720. If three specific persons among 6 insist on following each other, how many ways are possible? So for this one, we have 1, 2, 3, 4, 5, 6, but 3 insist on following each other. So we're going to consider them as one group, second group, third, and fourth. So that would be 4 factorial. But this 3 can be arranged in ABC, BAC, and so on. So that would be 3 factorial ways. So that would be 4 factorial times 3 factorial. So that would be equal to, yes, 144. Now this time, two specific persons among 6 refuse to follow each other. How many ways are possible? So first, let's consider them being together. So in that case, it would be 1, 2, 3, 4, 5, 6, grouping the two together. So that would be a total of 5 factorial, and then the arrangement of these two would be 2 factorial. So it would now be, um, if you're going to have away from each other, it would now be equal to the total of 6 factorial obtained from the first problem minus 5 factorial 2 factorial. So the evaluation of this is left for you to do. Another example. In a multiple choice test, there consists of 5 questions. So you're going to answer all the 5 questions. So 1, 2, 3, 4, 5. Each with 4 correct answers, or each with 4 possible answers, of which only one is correct. In how many ways can a student check of one answer to each question? So for question number 1, there are 4 options. Question number 2, 3, 4, and 5. So applying multiplication rule, this would be 4 raised to 5. In how many ways can a student check off one answer to each question and get all the answers wrong? So from the 4 questions, there is one correct answer. So if we're not going to choose the correct answer, there would be 3 wrong answers. So that would be 3 times 3 times 3 times 3 times 3. So that would be 3 raised to 5. This is somewhat similar to the previous example. How many 3-digit numbers can be formed from the digits 0 to 6 if each digit can only be used once? So 3-digit numbers, so first, second, and third digit. The first digit can be any of the 1, 2, 3, 4, 5, and 6, so that would be 6 options. For the second digit, all the 7 digits can now be used. However, the first one used can no longer be taken again, so that would be 6 ways. And for the last digit, from the 7 digits available, we remove the first 2 digits taken, so that would be 7 minus 2 is 5. So all in all, we have 6 times 6 times 5, which is 180. How many of these are odd numbers? So to get the odd numbers, we must put the last digit to be either 1, 3, or 5. So we have 3 options. For the first digit, there are 2 possible restrictions that we might be violating. So that is taking 0 and taking the last digit taken already. So that would be from 7, we remove 2, so that would be 5. For the second digit, there are 7 possible digits and we're going to remove the 2 digits that we have already taken, so that would now be 5. So this would be 5 times 5 is 25 times 3 is 75. If you want to take the even numbers, it would be 180 minus 75. How many are greater than 330? There are 2 possible cases. Case 1, uh, if the first digit is 4, 5, or 6. And another case, case 2, if the first digit is 3. If the first digit is 4, 5, or 6, so you have 3 possible options for the first digit. While for the second digit, we have 7, and you remove the first digit already taken, so that would be 6. And for the last digit, it would be 7 minus the 2 digit already taken, so that would be 5. So this would be 90. While for case 2, if 3 is the first digit, so you have no option but to place 3 as the first digit. While for the second digit, the possible digits or the possible numbers can be 4, 5, or 6, so you have 3. How about 3? Can 3 be a second digit? Yes. 3 cannot be a second digit because there would now be a repetition of digits in 330. While for the last digit, you have 7 options. You remove the first 2 digit already taken, so that would be 5. So this would be 15. For these 2 cases, the total is 105. In how many ways can 3 oaks, 4 pines, and 2 maples be arranged along a property line if one does not distinguish among the trees of the same kind? For this one, we have 3 plus 4 plus 2, so 3, 4, and 2. The total of this is 9. So this is a distribution of 9 into 3, 4, and 2. So this would be 9 factorial over 3 factorial, 4 factorial, and 2 factorial. So you do the simplification of this with your calculator. Next, a part is labeled by printing with 5 thick lines. So you have 5 thick, 2 medium, and 4 thin. So in if each ordering of the 9 lines represent different labels, how many different labels can be generated using this scheme? So 5 plus 2 is 9. 5 plus 2 is 7 plus 4 is 11. So this would now be 11 factorial over 5 factorial, 2 factorial, 4 factorial. Next, a young boy asked his mother to get 5 Game Boy cartridges from his collection of 10 arcades and 5 games. So he is asking for 5 that comes from 10 arcade and 5 sports. So we are going to select, so this is a total of 15 cartridge. So from the 10 arcades, we're going to select 3, and from the sports, you're going to select 2. How many ways are there that his mother will get this cartridges? So that would be 10, and we're going to select 3, and also 5 selecting 2. So multiplying the result, that would be the final answer. Next, how many ways are there to select 5 players from a 10-member tennis team to make a trip to a match at another school? So there are 10-member tennis team, and we're going to select 5 that would go to another school. So that would be selection of 5 from 10. Next, a bin of 50, so we have 50. We are going to divide this into 2 groups. One is the 47 non-defective and 3 defective parts. A sample of 6, so we're going to select 6 from these 50 parts without replacement. If each part can only be selected once and the sample is a subset of 50, how many different samples are there of size 6 that contains 2 defective parts? So from the 3 defective parts, we're going to select 2, and since we need 6, so 6 minus 2 is 4. So that would be 47 combination 4 times 3 combination 2. Next, a group of 30 people, so there are 30, have been trained as astronauts to go to the first mission to Mars. How many ways are there to select a crew of 6 people to go on this mission? So there are 30, we're going to choose 6. Assume that all crew members have the same job, so it doesn't matter whether you have a specific skill. So it would just be combination. You're not going to arrange them into according to a certain position. Next, suppose that there are 9 faculty members in mathematics department and 11 in the computer science department. So 9 for math and 11 for computer. How many ways are there to select a committee to develop a discrete math course at a school if the committee is to consist of 3 faculty members? So from the faculty members of mathematics, so we're going to select 3 and 4 from the computer science department. So that would be 9 combination 3 times 11 combination 4. So please evaluate this. These are the references that you can use to study this topic.